G4DPZ and his sidekick Carlos, G3VHF, who are going to talk to us about portable satellite operations and getting into amateur radio satellites.
That's all right, you start.
Okay.
Move it around.
You saw that, didn't you? Testing. Very good morning. Stand up light. Very good morning. Nice to see such a large audience. Carlos and I normally run this beginner session as part of the AMSAT Colloquium on a Friday afternoon before the main event happens. But because we thought it was a good idea to do this for the general conference itself, we get a bigger audience, and wow, thank you very much for coming. I'm G4DPZ, Dave Johnson, profession is a software engineer, but been a licensed radio amateur for 45 years now, and at least 30 of those has been working with amateur satellites in one form or another, either as an operator. Then I got cajoled into joining the AMSAT committee, and I think I've been a member of the AMSAT committee for about 15 years now, thereabouts. Carlos, would you care to say something like yourself?
Yeah, good morning. I'm Carlos Eavis, G3VHF. I'm from the YTS, or the Youth Creation Scheme. I've been in amateur radio since 1973. At the time, I wish I'd actually taken up knitting, because by now I'd have a cupboard full of useful jumpers and jackets rather than a whole box of wires that you never know what I might do with them next. One box marked 2 inches, another marked 1 inch. These are all things, of course, as a true amateur, we never throw anything away. You never know when it might come in handy. The problem is I can't get in the garage anymore because I can't get in there because everything that might come in handy is buried somewhere at the back. Likewise, been AMSAT Colloquium since 2001, I think. Haven't missed a year yet, which has been rather entertaining. As my colleague rightly said, we normally do this on a Friday afternoon, generally after the bar has been opened. So this is probably the first one we've ever done, A, on a Saturday, secondly sober, and also with more than 5 people in the room, which is rather shocking. But hopefully we'll try and keep you relatively entertained.
So this is going to be somewhat off the cuff. We've done it so many times now with the slides just sit behind us and we just chip. Thank you. It is a ding-dong conversation, this. Where does all this come from? In about 1962, thereabouts, a load of radio amateurs got together to design a small satellite based on something else that had gone up fairly recently by some of their, I should say, Russian adversaries at the time. Sputnik went up in 57. Of course, there's the, not quite Star Wars then, but a lot of animosity, a lot of war, a lot of Cold War going on, and the Americans were trying to catch up. They had quite a few failures, but they actually got a long way along the line to actually launching quite a few spacecraft. Fairly primitive ones. Mechanical design was pretty ropey, including the use of concrete ballast on the top of the rockets for mass balance. We'll see what happens next.
Well, from small beginnings, Oscar 1 was launched 1962. So as you can imagine, we've been playing amateur satellites as radio amateurs now for 55 years, which is a pretty impressive record, especially when you consider this is way before we managed to get a man on the moon. It only transmitted for 3 weeks, a very simple CW beacon. But if you can imagine, at that time, to get something into space was actually quite incredible, let alone for doing it as an amateur payload from a group of non-professionals. I say non-professionals, these are not guys who just sat at their office and thought this was a good thing to do. These were generally people working within the electronic world, the satellite world commercially, but they were building things at home in their garage. And the outcome was Oscar 1. And this is continuing really up to today, because an awful lot of satellites are still designed, still constructed at home by people who work in the industry, but have got access to various equipment that we generally wouldn't have, test facilities. It takes a long time and a lot of effort to get a satellite into orbit.
We've come a long way since that Oscar 1. From something very primitive to something extremely ambitious. Oscar 40 was, you can see from the scale of the device, if it's turned on its side, it's almost man-high. The gentleman on the right with the bunny suit on is Peter Gulzow, GB2OS, the president of AMSAT-DL, who's not sure if he's in the audience here, but I drove him down from Birmingham Airport at midnight last night. So he's doing a presentation on the next generation of satellites, which we'll talk about in a few minutes. It was very, it was almost outrageous in what it could do. You can see from the antennas on the top of the satellite the number of bands it could work on, all the way from 2 meters all the way to K-band, I think. With, I think there was a laser diode on board. It was quite sophisticated in terms of what it could do, in terms of its usage. It was meant to be a highly elliptical orbit. In other words, instead of being seen for just a few minutes at a time, it would be seen for several hours. Went out to 60,000 kilometers by accident. It was only meant to go out to about 35. Several transponders, all could be switched between them, so we could have a matrix. Data modes for the telemetry on the downlink was interesting and is still in use today, some of the techniques. It was also used for GPS determination, because normally GPS is at MEO or LEO. This went way beyond that, that's 60,000 kilometers, and they actually managed to condition the satellite and do validation of GPS even at that range and that speed as well.
AO40, of course, as we've just referred to, was very ambitious and unfortunately was a victim of its own engineering success. If anybody in the audience owns a BMW or an Audi, you'll understand the true meaning of over-engineered. The normal progress of building a satellite, especially one that's got a stabilisation system that can be fired in orbit, is to put a nice plastic plug on the end of the exhaust port to keep all the dust out. Unfortunately, the Germans decided that a brass carcellated screw fitting would be far better. It sat on a launch pad in Russia. Somebody forgot to take the brass plug off the exhaust port. Device went into orbit. Many months later, they decided to stabilise it. They fired the exhaust port that turned into a combustion chamber and blew half the side of the satellite apart. Had they used a plug, it'd been fine, and had somebody not forgotten the little tag that said remove before flight, it would have been even better, but they didn't. It's a shame, because it was many, many thousands of euros construction design, all to go up in smoke. But we hope one day maybe the batteries will go open circuit, the solar cells will start working, and it might start kicking back into life. But while that one operated, we used to sit down at Guildford merrily with a 2.4 gig download, 2 meter upload, or 77s uplink, working Mexico, Texas for hours at a time. Wonderful satellite.
Including mobile.
Sorry?
Including mobile.
Including mobile, yes. Oh, we can't go into driving around the car park with a satellite dish in the early hours of the morning, hanging out the back of a convertible window. No alcohol was involved, officer, honestly.
I have a question. How many people have operated satellites at all in their amateur lifetime? Oh, thank you.
You can all come up here, we'll sit there.
Yeah, jolly good. Somebody else can give a talk. How many this month? Thank you. And how many this week? It's putting in the same crew again. Thank you. We usually start this question because one of my colleagues in the US has got a lovely video that usually asks the question, how many do you think are still available? Well, we can't run the video, so I've got to do this very quickly because we're short of time. These are the number of active satellites at the moment on the left-hand side.
Active amateur.
Active amateur, I should say, yes.
Right,
and not including educational CubeSats or experimental CubeSats, but ones you can either work FM or linear transponder on board. We're capturing this on video, but you can see the link at the bottom, and it's from our colleagues in the United States. This page indicates how many times the satellite's been heard, and when in time. A considerable number of satellites, I think, I've lost count now. If somebody would care to count that for me. But we've got a clip further on in the presentation, which actually shows the footprints of all these satellites at the same time over the Earth, and it's amazing. It's almost total coverage of the Earth, covered by something at a point in time. Go onto the site. You can actually use the site to register reception of the satellite, which helps everybody around the recent show what's available. One of the good ones is the ISS FM, because they have been known to come on, not recently, but certainly in the past few months. It's nice to know when the ISS is active.
Comment made by Kenneth earlier, for those that were in his presentation, was the problem with amateur radio, electronic stuff in general, is acronyms. And as you can see, there are the various acronyms, and I shan't read them all out because you'll get extremely bored, that you'll tend to hear when people start talking about LEOs, low Earth orbits, high Earth orbits, when they start talking about Doppler, frequency changing. Doppler shift is normally demonstrated in a school with a buzzer and a tennis ball being swung around the head, or in a city school somebody steals a handbag and listens to the police car chasing him down the street. The way in which it's demonstrated with us with satellites is hearing the change in frequency as the satellite's moving, but it normally requires you to do one thing with an amateur radio that you generally never have to do, which is change your transmit frequency while you are transmitting, same way changing your receive frequency while you're receiving. That's something which tends to confuse a lot of people, because they're sitting there going, why is he moving frequency? Because unfortunately with Doppler shift, the frequency is changing at the satellite, and you'll go outside the satellite's passband. Uplinks, downlinks, acquisition of signal, loss of signal, they all require you to end up understanding the various acronyms, and people get a little bit confused at the beginning with this, but it soon becomes second nature, and in the end you realise the more you drink, the easier it becomes.
I'm humming. The satellites we're predominantly using are low Earth orbit, which I mean, a slide slightly further on will actually show more of what that means. But you're limited in time in terms of how long you can see a satellite. It can be from literally 30 seconds on the horizon to a horizon-to-horizon path overhead, which may be, for the ISS, 12 minutes, I think. Max 12 minutes. Something a little quicker, probably about 12 minutes, averagely about 8 minutes. So you have to be able to know where it is and when it is. That's one of the more important things. The little antennas that Carlos has got behind him, the arrow, basically point it vaguely in the satellite direction by hand.
The wrist having full azimuth and elevation capability.
The beam width on that is quite wide. We'll talk more about that in a second, but that's typical of the thing you're pointing at, the antennas.
LEOs, low Earth orbits, as the name describes. These are generally staying the same height from the ground as they orbit the Earth. They're almost in a polar orbit, orbiting once every hour and a half. I'm sure most of you are aware that Isaac Newton in Principia came up with the idea that if you went to the highest mountain on Earth, fired a cannonball, with enough speed the cannonball would head towards the Earth, but the Earth would curve away from it. And that speed's 17,500 miles an hour, which is the speed of a low Earth orbit satellite. The ones that we've got fall into two categories. We've got standard FM repeater in the sky, frequency up, frequency down, two different channels, quite easy to operate. And then we have linear transponders, a chunk of contiguous spectrum which allows you to send an SSB signal up, SSB signal down, hearing your uplink and downlink simultaneously. These linear transponders means you can have more than one conversation going on at any given time on the satellite rather than just being a one channel. And the problem with the one channel, it tends to be a power fest. He who has the most RF uplink is the one that generally gets to be heard on the downlink. The linear transponders, on the other hand, give for a greater opportunity. I should have said, of course, these generally operating on the 2 metre and 70 SEMS band, but some of the recent ones, like AO51, was frequency agile. It could also operate on 23 SEMS and on 2.4 gig.
Sorry? Yeah. Okay, we're talking about satellite orbits. It depends where the satellite's launched from, to a large extent, and what the launch opportunities are. The Indians, the Chinese, the Russians predominantly launch into an orbit that almost goes over the North Pole, but is usually off by about 3 degrees. So it's what we call an inclined orbit. We do that such we can maximize the amount of solar radiation we can see to charge the batteries via the solar cells. Other opportunities are, of course, in Florida for the ISS missions and SpaceX, etc. They're tending to be launching into equatorial orbits because they're low in latitude. It's easier for them. And to launch something out over the Atlantic or over the Pacific, if something splashes, you're not going to hit a piece of mainland. So we have 2 types of orbits, inclined, and I think probably the next slide talks about the next set. No, coverage.
Coverage, of course, is the amount of the ground the satellite can see. This is logically determined by the height of the satellite. The ISS is only 250 miles up, so it's quite limited. This one, I think, is FO29 or FujiSat. The concept is if you are anywhere within that footprint, you can get a signal from the satellite and send a signal up to it. So, of course, if you logically want to work 2 stations, if you're over there in the United Kingdom, you've got no problem working into northern Canada. Haven't quite got to Florida, but you've got the USA. So it's quite a large footprint. And with no disrespect to our European colleagues, an awful lot of UK amateurs do wait for the footprint to shift out of Europe. So it's just covering the UK because you're then not fighting with all the QRM from all the stations in Europe who are shouting at the satellite. It's a very good satellite footprint. The problem is we're getting less and less of the higher orbit ones and more of the lower orbit ones, which give a far smaller footprint. Think of this almost like grey line DXing. You're waiting until the very last edge to get the furthest possible contact. To be fair, I've done this sitting in a car park in Leicester talking to Fred in Martha's Vineyard on the east coast of the United States. Quite simple with just a handheld and an arrow aerial.
A little aside on that. Depending what your latitude is, depends how many satellites you can see. We're fortunate because a lot of the satellites are highly inclined orbits. They all go over the pole. So we'll see them at some point during the day. Our colleagues down in Florida at lower latitudes don't see quite so many. But they benefit from the ones that are actually in equatorial orbit. We talked about low Earth orbit. We've talked about elliptical orbits. We all know about geostationary orbits or geosynchronous orbits. We're fortunate that our colleagues in AMSAT Germany, AMSAT-DL, have been offered a ride share on a commercial satellite. As Graham said in the previous presentation here, we'd hoped to announce it today. These things slip. We haven't got a date, but it's going to be. We think it's going to be sometime next year. That's not me saying that. Peter Goulzow is giving a presentation later on today about the. I think it's today about the satellite that's been proposed. As I say, ride share. So we get all the benefit of the commercial satellite's power supplies. It's at geostationary. It's mid-Atlantic, so it covers. It doesn't cover enough of the US, unfortunately. So our American colleagues are a little bit miffed about that. However, they have an alternative. It's provisioned us as for those who came along to the previous presentation as a backup communication system as well. So if anything dies on the main satellite, they can use the onboard systems. It's not being built by AMSAT-DL. It's being designed by AMSAT-DL by a commercial company. So that's another difference to it. Peter's going to say more about it later on.
CubeSats are something which has become quite an interesting project for both radio amateurs and for universities. A couple of years ago, 2013, AMSAT-UK, along with assistance from other organisations in Europe, he said looking at Wouter in the corner, launched our current FunCube, which is the little satellite that's advertised on here. A CubeSat meaning exactly that, one single cube. You've got the receiver, the transmitter, the power supply, and all the computer interface inside of one device. AX25 protocol is available in some of the CubeSats for those who want to try APRS from a satellite. There are, in this case, it's a linear transponder. It gives you the opportunity of quite a few different stations. With the FunCube, it's also just putting telemetry data down throughout the week for schools to pick up signals from a satellite, which is just a very simplistic receiver. There's also an uplink of data messages so the schools can have messages put on there. It was effectively initially designed as an educational satellite, but it also has the advantage at weekends for us to use it as a linear transponder. CubeSats in general, though, we have multi-cubes where you end up with a 2U, a 3U CubeSat. The bigger they are, of course, the greater the expense comes when they need to be launched, but at least you can start adding more and more packages to them. This is where universities and amateur radio comes together, because they are utilising our frequencies to be able to do their experiments, but it gets the students also licensed. So for us, more radio amateurs, for them, more technology.
You'll see at the bottom of the slide there's a couple of links. Unfortunately, we can't get them to run. The one at the bottom is Celebration. When we launched FunCube, it was launched from India, yes. No, Russia, I beg your pardon, yes. Plesetsk. So I'm going to get prompt from all sides in there. Thank you. There. That was 4 o'clock in the morning, the launch. We saw it at 6:30 for the first pass. And somebody in the corner sent the first command to it. Yep. Yes, yes. That was what Celebration, and if you care to come and find us later, we'll show you what the celebration was at 6:30 in the morning with a bottle of Bollinger and a bucket of pork scratchings.
Only the best.
We've talked about CubeSats and alluded to education. In North America, the US Navy use satellites as one of their education techniques for the midshipmen. So basically, it's a semester or several semesters of learning for mechanical engineering, electrical engineering, etc., project engineering. Unfortunately, like all student projects, students move on. So you see a lot of CubeSats start but never finish. This is the same for the US students. They've gone through their training, they end up on a ship as a midshipman, and 2 years later the satellite actually gets launched. So there are a lot of delays and probably some disappointments in this. One thing we always use this slide for is our satellites are quite small. We also have to be very mindful of all the other devices on board the launch vehicle. So we can't have things hanging out like antennas. Well, these are some antennas sticking out on here, and for those of you close to the screen, you can possibly see some numbering on the elements. I imagine you've all had tape measures, the springy ones. You've all folded it back and made it spring out again. This is exactly the technique that that they use on the satellites, even commercial ones. These are the variant of it. Yes. So this satellite's on 2 meters and 70 centimeters, and if you measured the length of that ruler, it's probably about the right length. They didn't have to measure it; they had it already. For
all the engineers amongst you, I'm sure you'll all appreciate a simplistic block diagram. Receiver, separate transmitter, separate aerials, and as you saw, nice metal tapes being used as the aerials. Doesn't mean that you just need to calculate the length of the area you want for the frequency, then look at it on the ruler and then cut it off. It's quite simplistic. For the receiver, transmitter, IF matrix, internal housekeeping unit or central computer. That's a little bit more fun because, of course, this also has to have various systems feed into it, from the solar panels to the battery charger. All you need to do is bolt this all into a box, strap it to a rocket, have 6 odd G pulled off when it hits a launch pad, and then go and live in minus 260 degrees environment, being attacked by UV radiation every hour of its life. What you call a slightly hostile environment. And one of the problems with the hostile environment, of course, is that you've got no convection, so you've no way of transferring heat out from the satellite out into the area around it. Bar charging it with sunlight. I mean, I did have one student who thought we could nip up there and change the batteries in the satellite. Rather expensive unless you're going to go and try and recapture it and repower it up afterwards. And all of this has to be in a small package that can withstand the vibration, the shock. It's quite a challenge. Hence, there's a nice satellite shaker available in Nordvik where you can build the satellite, and after you've built one, you've got it all working on the ground. All you do is you take it onto the satellite shaker and then you shake it until it destroys itself, and then work out what it's able to resist, and then you go and build another one. It's rather like type-proofing a car. It's fun, isn't it, Wouter? You can't beat doing that. Hours and hours of fun, you finally get it working, and then it's like picking up a big hammer and working out how many times you need to hit it before it breaks, and then think, next time I'll hit it one stage less.
Just checking the outer, and we shook it at Rutherford Appleton Labs, who very kindly gave us their shaker table. Is it 96G for a few microseconds? Yeah, we hit 96G. You've seen for the shape of the thing, it's a cube. So at one point, the boards are actually in the same axis as the shaking, so it gave maximum flexure. Nothing fell off, did it? No. It was fine. It was fine. I'll take this one. We've mentioned FM and linear transponders. Not going to go into too much detail. As Carlos said, FM is basically bent pipe. Linear transponder is usually 100 kcs wide, no, not less than that. Depends what frequency we're using, uplink or downlink. We have to account for Doppler. It's not excessive. At 2 meters, it's about 5 kilohertz. 3 and yeah. And
told it to 20 at 77, 200 at 2.4 gig.
Thank you. It's significant the higher you go. Most people, well, we have been asked in the past, why don't we use co-channel, or why can't we go up on 2, down on 2? Well, if you've ever seen a repeater setup, the cavities stand about so high. To launch something like that, it would be slightly ridiculous. So that's why we use up and down on 70 or on mixed frequencies.
Well, threats to satellite, it starts on the ground, as you've heard, when you start shaking them. It becomes next when you start putting them into a rocket and hope that doesn't hit any resonant frequencies which are going to destroy it. And then by the time it's got into its rather quiet neg 260 degree temperature, being attacked by UV radiation, that's another problem. And of course, you've got these wonderful belts around the Earth. Some of you may have heard of the Van Allen belts, nice belts of radiation that satellites have to try and exist in. Also, of course, bursts from the sun. And every now and then you get these nice minor magnetic pulses that whiz off from the surface of the sun, and 8 minutes later, Houston, we have a problem, none of the satellites are working. They get hit by large amounts of RF energy right the way across the spectrum. So it is a very hostile environment for a satellite to exist in. But the fact, testament to the builders and the designers, we've had some of these up since the mid-1970s, and with the exception that the batteries are completely dead, they only work when they're in sunlight, they're still functional. So they're doing rather well.
Sorry? If we do a Friday afternoon demonstration or presentation like this, we normally wander outside the hotel in Guildford and wave antennas like that around. Ourselves, Drew, Glassbrenner from the US, either on FM or SSB. and people are always amazed that we're actually getting away with something as small as we do. We'll show you a few more slides about the equipment. But it's mixed mode, 270 and various other frequencies, but it's small equipment like this. We're not going to do the demo, unfortunately. Come and talk to us later. Quick overview of the equipment. Antennas in terms of handhelds and base station, preamps and phase switches. Unfortunately, we haven't got a photograph of the ARIS setup that we use for IOTA. There we go. Something very, very similar to that, but on a 60 or 70 foot mast, wasn't it? I think. The radios that are available and some of the tracking software. We'll whiz through this because I think I'm aware that we're getting short on time.
Handheld antennas, two predominant ones that have been in use for quite a few years. We have the Arrow. This has been made from the Arrow tubing. Very light, 2 meter 70 sems in one shaft. It's got a duplexer in the handle which allows you to hook it to the single output of a radio. Now these duplexers are rated at probably no more than about 10 watts. I have seen some enterprising people attempt to hook one of these to a 350 watt amplifier and then wonder why they start screaming when they press TX. It's not designed for you to hold an aerial at 350 watts. At 350 watts, get as far away from the aerial as you possibly can. But you don't need that sort of power level for any form of operating satellites. The other one there is a bit more of a modern version. It's a log periodic, 2 meter 70 sems. Because it's log periodic, it doesn't need any form of duplexer. But again, even at 6 inches away, I urge 350 watts is not the way to go unless you wish to meet your maker in any time soon. These aerials give you the opportunity of 2 meters up, or 70 sems up, 2 meter down, simultaneous transmission reception, fairly wide. All you need to know is the direction the satellite's coming from and the azimuth and elevation you expect it to be at. That's all, not a great deal of information. Hooked up to a simplistic handheld and you've got a satellite station.
And you can make your own. These are priced at about 110, I think, thereabouts. Sometimes available from AMSAT-UK. The Arrow is actually a US sourced device, as is the Elk. But I believe that one of the European companies is now starting to sell the Arrow. But there are designs on the web for the usual sort of chocolate block, screw it to the piece of wood, screw a piece of aluminium through it, and they just work, because that's exactly what the Arrow is, just made commercially. As Carlos pointed out, you do need a multiplexer, a diplexer rather, to actually be able to use a single wire from your full duplex transponder, or 2 wires to a pair of rigs. A pair of rigs works equally well.
Here we have an erstwhile colleague of mine, Howard Long, G6LVB, who, as you can see, thought it was raining, brought out his umbrella, decided didn't need that, decided to use it as a parabolic reflector for 2.4 gig. This, off memory, was at Leicester, I think. Operating AO40 very, very successfully. The nice thing about AO40 at high elliptical orbit, it meant that you weren't chasing it across the sky very much. It took the best part of 6 hours for it to go out and then come back in again, so you had a fair bit of time pointing in the same direction. A simplistic, or relatively simplistic, portable station. Howard and I tried this many times. In fact, I think we managed a long path communication between myself on the other side of the grass verge using something very similar to talk to somebody via a satellite. It was only 56,000 kilometres in that direction, so we sent a voice up there for it to come back, then walked across the field and went, "Could you hear me okay?" Wonderful way of using communication. Rather like Skyping somebody in your own living room.
We mentioned the sort of portable operation. The slides behind the image are a variant of this. Commercial equipment from Wemo in Germany, a pair of crossed antennas on 2 meters and 70, yet another umbrella, and the rotator is from Yaesu, the 5500. that's the sort of typical home base system that I've got at home, and a couple of other variants of it too. We talked about rigs. It's easiest to get on with a handheld. We've already heard from Kenneth this morning, very, very small number of watts to get up to the ISS. In fact, the ISS on the Ericsson is 5 watts. So they're only downlinking to us with actually a slightly modified handheld. So an individual handheld or a pair will work quite adequately.
Bear in mind, of course, the base station equipment does come with it something which most of your good ladies at home will object to, and it's called cost. That sort of aerial installation is not exactly cheap. Likewise, though, with the transceivers, looking at that list, it's interesting. The FT847 is obsolete, the IC910 is obsolete, the 736 is obsolete, the 910 probably should be. Did I say that out loud? The TS2000, on the other hand, it's only been going for 17 years and it's still in the catalogue. The main advantage of these transceivers is that they're able to receive and transmit and change frequency all at the same time. Most transceivers are not full duplex. You can use a non-full duplex transceiver, and we've done it with an FT817, where you program up 5 memories for the difference in the frequency change between VHF and UHF, and then you guesstimate where the pass is going to start. A couple of minutes in, you change to the next memory. A couple of minutes in, you change to the next memory. The disadvantage is you can't hear your downlink, so you don't actually know you're getting into the satellite, as well if you can hear your downlink at the same time as your uplink, you know for sure that you're getting in. All these base stations will do any of that. In fact, they're all still quite serviceable, and they're all pretty good they're all fit for purpose, but at a price. Plus 100 watts the satellite's a bit excessive.
Yeah. We've talked about commercial rigs, FM rigs, linear transponders. This is the bottom picture is Drew at the convention last year, I think, with my erstwhile colleague just off the side of the photograph. Sorry, Carlos. This was the typical several thousand kilometres for 2 metres apart. But the nice picture at the top is a pair of 817s from Evo, PA1IVO, who has a portable set. And what's actually in Drew's bag is actually a similar configuration with a pair of 817s. I know we're at time now, so I'll just run through a final set of slides.
All the active satellites that were listed earlier, every single one of those circles you can see on the board is a footprint currently from one of those satellites. Now, admittedly, as you can see, if you're within the footprint, you're able to use them. Because these are low Earth orbits, they're not geosynchronous, they're moving around the Earth all the time. You get 10-minute windows throughout the day. So it's not a case of, well, I've only got one satellite, I can only work it once a day. There's lots of different satellites out there that you can either just get data from, or you can put a QSO through them. So it's becoming more and more crowded. A couple of years ago, we were getting quite low on active available satellites. Now it's improving quite dramatically.
Just a couple of quick slides. Lots of tracking software out there in terms of what's available for PCs and OS X. Google's your friend. This set of slides will actually be on our YouTube feed at the end of the conference. But certainly the AMSAT North America have an up-to-date list of these. There are other resources online, basically about satellite information in terms of what's up there, what the characteristics of the satellite are. A good site to use if you just want a quick look is Heavens Above. They give tracking for a great number of satellites based on your home location. Quick plug from me and for AMSAT itself. There are several mobile applications in terms of you can actually watch the satellites and get predictions on your phone. The one that I write is AMSAT Droid, and you'll note the word free. It's actually on the Google Play site. And the other one is Google SatWatch, which is an equally good one for iOS. I have no allegiance to that one, but it's very, very good. I think that's just about it. And thank you to our sponsors. Thank you very much indeed.
questions. While I wait for... Have we got any questions from the audience, please? George, wait for...
More an observation rather than a question. You talk about the full duplex, and don't forget that there's cheap Chinese dual-band handhelds about, and RTL dongles and many SDRs. So Carlos is choking because he's seen them on a spec cam.
Like a cheap Chinese receiver that can't hear anything if there's any noise within 1 million miles of it. Unfortunately, the receiver capabilities in those things are limited, to say the least. I've seen some of them that require a 4 to 5 microvolt signal before they'll even wake up. For a low Earth orbit satellite, absolute waste of time.
But there's still
unless you're in the middle of the Isle of Lewis, on the other hand.
But there's still lots of cheap SDRs about for receive. So
absolutely,
full
yes.
duplex should be cheap and available.
Yeah, with an SDR receiver that would be fine, but the handheld on its own, you'll struggle.
I don't think you want to knock the Baofangs too much, because it is a great way of people getting into amateur satellites at a very inexpensive price, and that then generates the interest for later on.
I don't disagree with you. The problem is when people come up to us, and we've had this in previous years, say, I've got this handheld, I've got an arrow, I can't hear anything. And you stroll in the car park with your Kenwood one and you go, well, this is a second-hand Kenwood one, it probably only costs 50 quid off of eBay, and we can hear it on here, why don't you think you can hear it on yours? And they're unfortunately listening to every lift motor, sign, fluorescent tube and everything else within a 100-mile vicinity. That's where the problem is with the Chinese handheld. The receiver sensitivity is brilliant, but the selectivity is awful.
Okay, thank you. Are there any other questions? Nothing? Okay, well, thank you. Carlos? Dave? Good?
Pleasure.
Right, the next speaker